Here's a good example of data transformation. It's a limited queue, which means a queue with a limited capacity to hold items. It can hold at most n items in a list named Q, with an index named P to say how much of the queue is occupied. Those are the implementer's variables. The user's variables are C, which is binary, and X, which is the same type as the items. From the picture, you see that the items occupy the space between 0 and P. If the items were people, they would be facing to the left. The front of the queue is the left end, and the back is the right end. Operation makeEmptyQ assigns 0 to P. Operation isEmptyQ tests if P is 0 and reports the result in user's variable C. Similarly, isFullQ tests if P equals n and reports the result by assignment to C. Operation join assigns X to position P and then increases P by 1. That works only if the queue isn't full. Operation leave has to get rid of item 0, and it does that by moving all the other items left one place and then decreasing P. That works only if the queue isn't empty. And finally, Operation front just assigns Q0 to X. All these operations are fast, taking no time in the recursive measure except for leave, which takes time P minus 1. The purpose of the transformation is so that all operations will take no time. The new implementer's variables are R, which is a list variable that holds the queue items, and index variables F and B, which stand for front and back. Here's the old picture again, and here's the new picture. The items are in the segment between F and B. Joining is pretty much the same as before, but leaving is just increasing F by 1, which is a fast operation. As new items join and old items leave, the queue sort of moves to the right, and when it bumps into the end, it just continues from the beginning again, moving cyclically around the list. When F is to the left of B, the items are between them. When B is to the left of F, the items are in the outer portions. So now, with the help of the pictures, maybe we can write the data transformer. There are two cases. The top line is the left picture, and the bottom line is the right picture. In the top line, it says that P is equal to B minus F, and that the items of Q between 0 and P are the items of R between F and B. The bottom line says that P is equal to n minus F, that's the front piece of the queue, plus B, which is the back piece of the queue. And the items of Q from 0 to P are the same as the items of R from F to N, followed by the items from 0 to B. Now we can transform. Let's start with makeEmptyQ. This is the formula using the old variables Q and P. makeEmptyQ was just P gets 0. And in the old variables, that's P prime equals 0, and the other variables are unchanged. Now we simplify, but let me save a lot of time and just show you the result. It says make F and B be equal. It doesn't matter which index they are as long as they're equal. So we choose something. That seems good for makeEmptyQ. Now let's try isEmptyQ. That was defined as C gets the result of comparing P and 0. In the variables before transformation, that's C prime equals the result of P equals 0, and all other variables are unchanged. Now again, I'll save time and show you the result. There are 4 cases. The first case says F less than B, which means it's in the inside mode with the items between F and B at the start of the operation and also at the end of the operation. But it doesn't insist that F and B are unchanged. It allows us to shift the items left or right if we want to. I can't imagine why we would want to, but the data transformation shows you all the possibilities, so it says you can shift the items while reporting whether the queue is empty. The next case starts in the inside mode and ends in the outside mode, in case you want to shift the items past the end. We don't, but there's the possibility. The next case starts in the outside mode and ends in the inside mode. And the last case starts and ends in the outside mode. Aside from all that useless shifting, what does it say about whether the queue is empty? In each case, it says that the queue is not empty. That can't be right. What about when the queue is empty? Something very interesting is happening here. If we look at the cases again, the case F equals B is missing. That would be the case where the queue is empty. An operation cannot control its input. It can't insist that F is unequal to B. isEmptyQ has been transformed into an unimplementable specification. That's one of the great things about data transformation. If you make a mistake in designing the new data structure, it transforms to an unimplementable specification. So you can't refine it to a program. It even tries to tell you what mistake you made. So what was our mistake? Let's look at the picture again. There was no problem transforming makeEmptyQ. The problem was with isEmptyQ. We can't tell if a queue is empty. And that's because F equals B could be empty if we're in the inside mode on the left, or it could be full if we're in the outside mode on the right. We need a new variable, m, to say which mode we're in. Here's what the data transformer was. And here's what it should be. I've added m to the top line, meaning inside mode, and not m to the bottom line, meaning outside mode. Now we have to transform makeEmptyQ again. Skipping all the details, the result is F gets 0 and B gets 0 as before, but this time M gets true. Now, isEmptyQ, which went wrong before. This time, the missing case is here. We have M, which means inside mode, with F equals B, and C prime is true to report empty. And we can refine it to a program. C gets the conjunction M and F equals B. Let me quickly show you the results of transforming the other operations. IsFullQ is also a test whether f equals b, but this time in the outside mode. Join puts x in position b and then advances b in a circular fashion. Leave advances f in a circular fashion. And front just looks at the item in position f. In each case, it's a refinement, not an equality, because we keep being offered the opportunity to shift the items if we want to. But we don't. Let me sum up a few things about data transformation. You don't have to have the same number of variables after the transformation, and the limited queue illustrated this point because after there were 2 more than before. Also, you don't have to replace the entire space of implementers variables if you don't want to. We did in the examples, but sometimes you just want to replace some of the variables. And if you do replace part, you can replace another part later. You can do it in parts. What you see people do in practice is to define a new data space and then reprogram the operations. That way, you don't know if you got it right or wrong. People make mistakes and they don't know they've done so. So we get bugs. What they should do is write a data transformer. Then you don't have to think up new operations. The transformer tells you all the possibilities. And if you make a mistake writing the transformer, you find out because you get an unimplementable specification.